Acceleration due to a change in the speed, not in the direction. The diagrams below show the successive positions of a girl during equal intervals of time. Describe the variation of the distance between the successive positions as a function of time. As for the first case, an observer, comes and look at the position of the girl and finds her at this position. Then after, for example, 1 second, he comes back and look at her and find her at the same position, and so on. So what does this mean? How can we describe the distance covered by the girl during the equal intervals of time? We can say that no distance is covered as time passes. This means that the girl is motionless, and this case is a case of zero acceleration because there is no change in the distance, there's no motion. So there is no speed, there's no change in the speed. So that's why there is no acceleration. However, in case 2, equal distances are covered during equal intervals of time. This means that the girl is moving at a constant speed. Like every second, she is covering the same distance. And still here, we consider that there is no acceleration because there is no change in the speed. However, in case 3, we can see that the distance separating the successive positions of the girl is increasing within the same interval of time. This means that the speed of the girl is increasing, and this is a case of positive acceleration. However, the opposite is true for case 4. The distance covered during equal intervals of time by the girl is decreasing. So we can see that d1 is greater than d2, greater than d3, greater than d4, and so on. So the distance covered during equal interval of time decreases. This means that the speed of the girl is decreasing, and thus this is a case of negative acceleration, or what we call deceleration. The rule for calculating the numerical acceleration for an object that is not changing direction, that is moving in one direction in one dimension along a straight line, A average is equal to delta V over delta T, where the SI unit of average acceleration is meter per second squared, and the change in the speed, delta here means a change, so the change in the speed is in meter per second, the change in time or the duration is the seconds. VF stands for final speed of the interval of time, and V initial stands for the initial speed, or VI stands for the initial speed, and as I know of the speed is meter per second. TF is final instant, TI is initial instant. Direct application. The following problems are based on actual amusement park rides. Fill in the blanks. Problem 1. One type of a ride falls straight down for 3 seconds. During this time, the ride accelerates from a speed of 0 meters per second to a speed of 30 meters per second. What is the average acceleration of the ride? In order to be able to apply the formula, we have to pick up the given. So let's pick up the given. Initial speed, it started moving from 0 meters per second to a speed of 30 meters per second, so this is the final speed, and the time needed is, the duration is 3 seconds. So what's the average acceleration? We have to apply the formula. A average is equal delta V over delta T equal V final minus V initial over delta T, 30 minus 0 meter per second over 3 seconds. Meter per second over second is meter per second squared, and the value is 30 by 3 is 10. Similarly here, we have a roller coaster that accelerates from a speed of 4 meters per second to 22 meters per second in 3 seconds. What is the average acceleration of the ride? The initial speed is 4 meters per second, the final speed is 22 meters per second, duration 3 seconds. So again, we have to apply the formula, which says that A average is delta V over delta T equal V final minus V initial over delta T, 22 minus 4, all meter per second, over 3 seconds, it's meter per second squared, and the value is 6. Now, application 2, studying the variation of V as a function of time graphically. The document 1 shows the variation of the speed as a function of time for a car moving on a straight line. So here we are back to stressing on that we're studying the case in which an object moves in one dimension and in one direction along a straight line. So indicate the speeds of the car at VO, VA, VB, and VC at points O, A, B, and C. So graphically, VO is 0 meters per second. Do not only write 0, you have to write the unit. VA, we have to do projection on the y-axis to know it's 30 meters per second because it's halfway between 20 and 40. V similarly 30 meters per second, and VC is back to 0 meters per second. Now to describe the variation of the instantaneous speed of the car as a function of time along OA, AB, and BC. So here we have three phases, three variations. We say that along OA, the speed increases from VO equals 0 meter per second to VA equal 30 meter per second as time passes from T equals 0 seconds to T equals 6 seconds. We can figure out here that the scale on the time axis is every 1 centimeter is 2 seconds. So here we have 2, 4, 6. So the instant TA is 6 seconds. Now along AB, the speed remains constant at 30 meters per second. It's important to mention, so even if the physical quantity is constant, you have to mention the value of it. So at 30 meters per second, as time passes from T equals 6 seconds till T equals 14 seconds. And finally, as for BC, the speed decreases from VB equal 30 meters per second to VC equals 0 meter per second as time passes from T equal 14 seconds till T equal 24 seconds. And here I want to stress on that you have to write the values, you have to write increase and decrease when you describe the variation of a physical quantity, from which value till which value. You have to be specific. Now calculate the acceleration of the car along OA, AB, and BC. You have to apply the formula. A average is equal delta V over delta T. So let's do it now. I'm gonna start here and then continue down there. So this is part 3. A average. I'm not going to repeat the formula every now and then. I can, in such questions, I can only write the formula for once and then do the substitutions directly for the other cases. So no need to repeat delta V over delta T of every now and then. So you can write it for once, then start working. For example, OA, A average, you can directly substitute. Here, continue, write the formula V final minus V initial over T final minus T initial. So A average for OA is VA minus VO over TA minus TO. You can say it's 30 minus 0 meter per second over 6 minus 0 seconds. And the value is going to be 30 over 6 is 5 meter per second squared. Now for AB, also directly, no need to repeat the formula, only do the substitutions. It is VB minus VA over TB minus TA, so it is 30 minus 30. We already found these values, meter per second, over whatever, 14 minus 6 seconds. 30 minus 30 is 0, 0 over any number is 0, so this is 0 meter per second squared. There is no acceleration because the speed remains constant, there is no change in the speed. And finally, along BC, we say that A average is equal to VC minus VB over TC minus TB. So VC is 0 minus VB is 30 meter per second over TC is 2024 minus 14 seconds. So as long as the speed is decreasing, we expect the acceleration to be a negative acceleration. So 0 minus 30 is minus 30 over 10. So it is equal to minus 3 meter per second squared.